Hello and welcome to this DCD talk on waterless two-phase liquid cooling for AI. I'm Emma Strutton, I'm head of channels at DCD, and today we are with ZutaCore president and COO Brian Lillie about the growing heat and power challenges driven by AI workloads and how waterless direct-to-chip liquid cooling is enabling the next generation of high-density data centers. So thanks very much for joining me today, Brian. How are you?
I am doing fantastic, and thanks for inviting me.
No, thank you for joining me. So, just to start us out, I suppose, just to set the scene a little bit with you, are you able to tell me a bit more about how you got into the data center industry? I suppose what experiences have shaped how you think about infrastructure innovation, and as we are talking about today, especially around efficiency and cooling.
Sure. So my background, I really started my career in the United States Air Force, working in satellite command and control and systems. Actually, starting out with systems and systems engineering. And I moved through a number of different parts of the tech industry. Started out at a computer manufacturer called Silicon Graphics. If you remember, they made the dinosaurs in Jurassic Park. Moved to internet security, VeriSign, and then I spent 10 years in a very formative role at Equinix, one of the largest data center companies in the world. And I followed that with a tour in fiber infrastructure, so creating long haul fiber runs, again, infrastructure. And then cloud, running a significant cloud company at Rackspace. And then finally at ZutaCore, where, looking at this intersection of infrastructure and compute and these complex systems, how that's really come to fruition in AI. And, I kind of saw that, frankly, that thermal constraints power, and thermal's the flip side of power, that those constraints became the limiting factor much more than compute itself. And so it really shaped my mindset around efficiency and that it's not incremental, but that you actually have to design it in from the start. And really what drew me to ZutaCore was that we're not just talking about improving cooling just incrementally, but fundamentally rethinking how heat really is removed from the source. So that's what led me to this space.
Thanks so much, Brian. And I suppose following on from what you've just said, AI workloads are driving a new level of thermal and power demands. So from your perspective, how serious is the heat problem today and how quickly is it escalating?
Yeah, I think it's significant, and it's significant today. It's not really a theoretical problem. It's the primary constraint on AI infrastructure growth is, again, power and heat are the flip side of the same coin. And we're seeing densities jump from, I think it's actually kind of funny, a little silly, that I remember we used to build data centers for 4 kilowatts per rack, and that was a big deal. And now it's not only jumping from 4 to 10 to 20 to even 100, 150 kilowatts per rack. And so legacy approaches like air, if you look at the air radiators there, the fins are this high. Well, if space is a premium in a rack, you just can't take away the heat with air. And then there's even legacy liquid approaches. Single phase is the capability today, but even it's going to hit really a thermal wall soon. And because the pace is accelerating, the heat flux is growing. And so it's a right now problem, but it's really going to be a problem in the next few years.
Yeah, absolutely. Thanks, Brian. And ZutaCore's HyperCool uses a waterless direct-chip liquid cooling approach. So, can you explain how it works and why removing heat directly from the silicon is becoming essential?
Yeah, it's a great question because just describing the difference between single phase and two phase. So single phase, primarily using water, PG25, is blowing the water across the chip and taking the heat away that way. And you can imagine that as the heat flux coming from the chip itself increases, you have to blow colder water faster. And that's really the challenge with single phase. Now, single phase is doing a fine job right now, but as the heat flux increases, you've got to increase the pressure and the velocity, the flow rate, to the point where it's really unsustainable. Whereas the direct to chip two phase approach is the liquid, and we don't use water, we use a dielectric fluid, so we avoid some of the challenges with water and electronics. It's non-conductive, and it's sitting there right there in a reservoir above that chip. So as that heat goes, it's just like the water on, on a pot on your stove. You turn up the heat. All that means is it's going to boil sooner, but it's still going to boil at the boiling point of the fluid. And in our case, the boiling point is really only 4 degrees more than the fluid. So it's changing state from liquid to vapor. That's why it's called two phase. And what happens is even as that heat flux increases, we can just take that vapor away. So it's low pressure. You're not, the flow rate is very low. And because we're removing the heat at the source, we're eliminating a lot of the inefficiencies of indirect approaches to removing that heat. So it's really, you can cool hotter chips so you get higher performance. You get lower energy consumption because we're not blowing this at a high rate. So we don't need big pumps. We can use little pumps. And it really is going to be able to, and has, scale in a much, much more efficient, cost efficient and energy efficient way.
Yeah, and you mentioned scalability there, and I suppose as AI infrastructure scales, what are your customers asking for today, and how is that shaping your technology and some of your deployments?
Yeah, the market signal we're getting now is not only do they want to cool these higher densities, but they want to be able to do that at scale, and they want certainty at these higher densities at scale. And when you talk about next generation GPUs, how can you do that without having to redesign the entire facility? And so one of the things we're seeing is we want modular deployments. We want deployments in existing data centers. How can you help me hit these thermal heights, in essence, in the existing facilities I have? So really, how do I extend the useful life of my assets, my data center assets, in a retrofit friendly way? So I think that as you build AI factories and you're designing it from the core, from scratch, greenfields, we call them, that's one thing. But there's also a tremendous amount of existing infrastructure out there. And how can we extend the useful life of those assets? We're getting asked that a lot. So it's both greenfield from the beginning, thermal cooling at the core, to how can you retrofit my existing in a friendly way.
Fantastic. Thank you, Brian. And energy and water are both becoming constraints on data center growth. And you mentioned obviously waterless liquid cooling, but when it comes to energy and water, how much of that comes down to cooling efficiency, and how important is reducing water usage as operators scale AI infrastructure?
Yeah, it's a great question. This has become a real issue. Data center projects are not only being canceled or limited or canceled because of a lack of power, but increasingly it's because of a lack of water. So coming up with innovative ways to power and cool these facilities is crucial to really the success. Because when you think about it, cooling can represent a pretty significant portion of the total data center energy. There's a factor, this PUE factor, which is how much of the total energy are you driving towards compute versus being used around that compute to either power it or cool it. And so improving the overall system efficiency is crucial. And it's really a global issue. And so this waterless approach and high efficiency approach, if we can use less energy, because again, less, the pumps, just to give you an example, at 1 megawatt, a 1 megawatt CDU single phase takes about 70 kilowatts to run that system. A 1 megawatt two phase CDU that we've built that we've now tested takes 7 kilowatts. So it's a factor of 10 less energy to run the cooling infrastructure. And if we can do that in a way that's waterless, then now when you're talking to the community that you're building this facility in, or that you're partnering with, you talk about, we are going to use less of the energy and less of the water that really should be, frankly, for humans and not for computers. In fact, we have a shirt that says "Water is for humans, not for servers," and it's maybe one of my favorite shirts.
Yeah, very good. And I suppose to finish us off, as these densities continue to rise, as we're seeing at the moment, how should operators be designing data centers today? And looking ahead, what do you think data center cooling will look like, and what role do you think ZutaCore will play?
Well, I think that data centers, in terms of building new, I talked a bit about intelligent retrofitting, but they should be designed for cooling from the core. So at the core is power and cooling, again, really, really important, and it's not an afterthought. So at the core, I think they have to, data center designers have to think about high density zones. They have to think about liquid distribution systems, taking it at a system level, and thermal architecture from day one. Then it really starts at the silicon. So I think the silicon providers, the NVIDIAs, Intels, AMDs, et cetera, of the world, have to think about it at the core, even back to the TSMCs and back to dies that are being created. So it starts at silicon. It actually then, the ODMs have to think about that in packaging. And we work with all of these guys. So we see the efforts they're placing. And then in the infrastructure, it has to be done from the beginning. And I don't see any way around a fully, thermal future that is liquid cooled. And it starts at the chip and goes all the way. We call it chip to chiller, or even chip to grid. And I think it is the key factor in designing these data centers for the future.
Yeah, absolutely. Well, we'll look forward to sort of seeing what you and the team at ZutaCore are up to. But unfortunately, I will have to wrap it up there, Brian. But thank you so much for joining me on this DCD talk. And I've very much enjoyed the conversation, and hope you have as well. So thank you for joining me today.
Thank you so much. And just remember, liquid cooling is no longer an option. It's a requirement.
Absolutely. Thanks, Brian.